Now we're going to discuss about different types of starting methods in single phase induction motor. Okay, the title of single phase induction motors types are starting methods. Both are same because in single phase induction motor is not self-starting. To make it self-starting, some method is required to be evolved to produce a RMF. Already we know RMF means revolving magnetic field, particularly in stator field. This may be obtained by converting a single phase supply into two phase supply, which can be achieved by using an additional winding. That additional winding may be or may not be disconnected once the motor start picks up the 75% of rated speed, or by creating another field using a short circuiting band or ring. Accordingly, depending upon this method, you should to make a single phase induction motor self-starting. Okay, already we know that. Okay, can be classified as split phase capacitors, capacitor motors, or shaded pole motors. Okay, here the split phase capacitors is employed two-phase motor action because it's having additional windings. Also used that additional winding is in the auxiliary winding. Capacitor motors is started employing by two-phase motor section. Fusion auxiliary winding is capacitor. In split-phase motor, the auxiliary winding is starting winding, but here we are using for capacitor. That's only these types of motors are capacitor start induction or capacitor start the capacitor run induction. Next one is the saddle pull motors. These motors are started by the interaction of field produced by saddle band or short circuit ring placed around a portion of pole structure. Okay, here this one is a split phase capacitor type. The outer frame and this kind of motors uh, stator core of similar to the stator core of three-phase induction motor. We know that three-phase induction motor having a stator core and a rotor core. Yeah, here this is split phase. Split phase is outer frame is like a stator core of three-phase induction motors. It provides auxiliary stator winding called as a starting winding in addition to the main winding. These windings are placed in this test slots. Both the windings are put in a parallel. This purpose is to get a different currents and sufficiently displaced from each other so that a revolving field is produced. Okay, the ultimate aim is to generating the revolving field in single phase induction motor. The main winding, which is highly inductive, is connected across the line in the usual manner. The auxiliary or starting winding has a greater resistance and less reactance as compared to the main winding. The current in the winding, if the terms IS is indicated as a starting current, lacks the supply voltage, the term supply voltage is a Vs by lesser than angle phi s. Whereas the current in the main winding, the main winding is indicated as a IM, being highly inductive lags the supply voltages by greater than phi m. The two currents have a phase difference of some angle electrical. Theoretically, we can indicate as a theta degree. Thus, a revolving field is set up in the stator and a starting spark is developed in the rotor. This diagram is clearly indicated as a split phase capacitor, split phase induction motor type. Single phase supply is fed to the input of stator. Here the stator, it's connected to the main winding and the additional one more winding there. That winding is a starting winding. That starting winding is not directly connected. In between the starting winding is connected one centrifugal switch. Okay, through that centrifugal switches, the operations will be varying. Okay, in this phasor diagram itself, we can clearly understand that what will happen in these operations. The voltage, if we are considered for x-axis, some angle is lagging of main current or magnetizing current. That is a phi m. Phi m is indicated as a angle difference between voltage and the current. Okay, some of this current is of supply current. The supply current is some angle is deviation, that is a phi s. Okay, here the maximum voltage and the current angle is indicated as a theta. Okay, already we know that theta. Okay, theta is electrical phase difference between the supply voltage and supply current. Next one is um, performance and characteristics of single phase induction motor. The starting torque is twice the amount of full load torque. So the current is starting time to gathering 6 to 8 times more than the rated current. The speed fails with increases in load by only 5% to 7%. Otherwise, it's a constant speed motor. Okay, we all know the induction motor speed is ns equal to 120 f by p. Okay, but the induction motor actual speed is less than the synchronous speed. For the same weight, its rating about 60% to that of the body phase induction motor. It has lower power factor and lesser efficiency. Okay. In this type of induction motor, the power factor value is very minimum. That means 0.6. Okay. The efficiency also almost or less than 60% only. Okay. These are the speed torque relationship. Okay, at the starting times, the centrifugal switching is not operated. So the speed value is very minimum. Okay, after that, the centrifugal switches will be open. Okay, in this running condition, so more than the more than the 70% of rated speed. So the speed value will be high. Okay, in this statement, we can clearly understand through this speed torque characteristics graph. Okay, in this motor, in this capacitor start induction motor, the capacitor is connected in series with the starting winding. Okay, the purpose of this capacitor is improve the what are the drawbacks as we will face the split phase motor. In this motor, the angular displacement between IS and IM can be made nearly 90 degree and a high starting torque can be obtained. Okay, the starting torque is directly proportional to the sine angle of theta. Okay, so the capacitor starter connected in the starter winding is permanently or temporary. Okay, so the capacitor connections of the main winding is split up in 3 types. One is a capacitor start motor, another one is a capacitor run motor, and third type is capacitor start and capacitor run motor. Capacitor start induction motor, capacitor is a large value. Okay, so the motor will give high starting torque. Okay, this torque is directly proportional to sine theta. In case of phase angle, IM and IS is near to be 90 degree. Okay, capacitor is employed short time duty rating. Here, we are using the capacitor type is electrolytic type capacitor. Okay, this electrolytic type capacitor is connected in series with the starting winding along with the centrifugal switch. When the motor is obtained 70% of synchronous speed, the starting winding is cut off. Okay. After that, the construction wise, it's a similar for split phase motor. Okay. When we needed for high starting torque, at that time we are prefer for capacitor start induction motors. Example, refrigerator, we are using this capacitor start type of induction motor. Okay, these are the circuit diagram. In the circuit diagram, the main winding and the starter winding, centrifugal switch, all those things are same in split phase capacitor. The only deviation is this capacitor C is connected in series with the centrifugal switch. Okay, so the phasor diagram, the IS is leading of voltage. Okay, IM is only for lagging of voltage. Okay, some angle deviations, that angle deviation is 5s. Okay, compare the split phase, here the IS current will be increasing. That means the starting resistance, the starting current will be leading of supply voltage. Okay, these performance and characteristics, the speed is almost constant. Okay, within 5% of slope. So the high starting torque is more than full load torque. Okay, How much amount of more than means 4 to 5 times of full load torque. So it draws low starting current. The direction of rotations can also be changed, either interchanging of starting and running winding. Here this starting winding and the running winding is a main winding. If you are interchanged both the windings, okay, the rotation direction will be changed. Okay, this is the speed torque relationship. Here the starting stage, the torque will be okay, going to be a in the starting stage the starting torque will be more, but speed is very less. Once the speed will be reached for 70% of rated speed, the torque will be going to be a reduce. Okay, so it's both are inversely proportional. Next one is here capacitor run motors. Here permanently connected the capacitors are used. So paper capacitors we are preferring. In case of electrolytic capacitors cannot be used because the electrolytic capacitors is designed only for short time rating. Okay, so it cannot be permanently connected. Okay, here both main winding and the starting winding of equal rating. So the starting torque is lower about 50% to 100% of full load torque. So compare that the previous types, the capacitor run motors, the power factor will be high. So automatically the efficiency also increased up to 75%. Is the circuit diagram? Okay, in this diagram, the capacitor run motors, the capacitors are permanently connected. Okay, thank you. The continuity of types of single phase induction motors. The last type is capacitor start and the capacitor run motors. The capacitor start and the capacitor run motor, in these cases, two capacitors are used. One capacitor is connected to the starting purpose, another one is connected for running purpose. For starting purpose, we are using for electrolytic type capacitors. Okay, in these capacitors, once the motor reached 75% of synchronous speed, disconnect the supply with the help of centrifugal switch. Whereas the paper capacitors, the running winding, we connected for one more capacitor, that is a paper capacitor. That capacitor remains in the circuit of starting winding during running condition. This type of motor gives best running and starting operations. The starting capacitor, which is higher value compare the running capacitor. Okay, this is the important consideration under design aspects of capacitor start and the capacitor run motor. Performance wise, this motor is operated as two-phase motors and to provide best performance compare any previous types of capacitor types motors. At the same time, it produces noiseless operations. Starting torque is high, starting current is low. So it's due better efficiency. At the same time, it provide higher power factor. The only disadvantages of capacitor start and the capacitor run is high cost. Okay, in this torque speed characteristics curve, clearly understand that in the starting condition, the speed is low, the full torque is high. Okay, then the speed will be reached. The dotted line is indicated as the curve to reach for the maximum speed. Okay, then the speed is going to be reduced to 0. Okay, these are the special features of capacitor start and capacitor run induction motor. Okay, thank you.